Bismillah ar-Rahman Rahim. This is a question we have June 2020 31 variant and question number 4. And we have mentioned y is equals to e to power 2x time to sine x plus 3 cos x. Job is what stationary point we find 0 to pi. What does 0 to pi means? It means 0 to pi. It means first two quadrants only. And find x coordinate and give answer 2 dp. So let's start. Job number 1. So find differentiation. So I call this u and there's a whole as a v. So u copy. So v derivative plus opposite now. V copy into u derivative. Repeat. U copy v derivative. V copy u derivative. So let's start. What is sign differentiation? All of familiar cos. What is the cos differentiation? Minus sign. So minus 3 sine x. And what about this differentiation? First copy as it is into 2. 2 come from where? From power differentiation. I will keep derivative equal to 0. Reason, stationary point. So you can see this one, this e to power 2x common out. I take common out in the same time. I save my time. This I'm copying as it is because this gone. So this full left behind. So cos x minus 3 sine x. In this circle, so this goes out 2 and this left behind. So 2 will multiply the bracket value. So 2 sine x and 2 3s are 6 cos x. Now either this part equal to 0 or this whole part equal to 0. I'm writing either this part equal to 0, which is not possible. Logic, if I want to bring it down, I will take a log. Log of both sides, log of 0 is math error, undefined, logically not possible. So cut it from here. This 6 plus 7, 1 got a 7 cos x. And 2 minus 3 got a minus sine x equal to 0. Either this equal to 0 or this whole thing equal to 0. Now bring sine on the other side. So 7 cos x equal to sine x. Cos goes under it. So I got 7 equal to tan x. Okay, now tan, all of you know positive where. So tan is positive here and here. But these are out of range. Only one answer comes. So when you take a tan inverse here, you can see that whenever if I take a tan inverse, and hold on, keep your eye in, he said 2 dp, radian, so we have to convert it, get into 2 dp. So, so degree mode, make sure degree mode, okay? So tan inverse of 7. My answer is coming, oh, sorry, radian mode, because I was saying before, radian mode. So 1.4288, he said 2 dp, this I don't need. So answer is 1.43. So alhamdulillah rabbil alameen, done. But let's talk about the next part. Next part is very interesting. Now we have two choices. Okay, I think this is easy. So this is actually this. So it means first differentiation is very, very clear. I have e to power 2x. This come from here. In the bracket, I am writing this. So 7 cos x minus sine x. So this is I have given. So now I have two techniques to do it. One technique, I will differentiate again by product formula. This is u, this is v. And after having then I plug in each x value, this one. If answer come positive, point of minima, negative, point of maxima, right? But today I'm going to teach you a new technique. That technique you are familiar, okay? That technique you are already familiar, that whenever for example, what the other technique? You know it very well. We will go for second derivative. Okay, I can do even that, but I'm going to teach a new technique. And what is new technique? If this is a point of maxima, this point just before, for example, what is this x value? 1.43. I'm not sure about it. Okay, that it is a point of maximum or point of minima. Okay, I will get it inshallah. So just before 1.43 is this number 1.42. Just after we have 1.44. I will, okay. Students, the rule. What? Look, I make a big diagram, then you can understand. So I just take a tangent at this point and find the gradient. Okay, and I find this gradient here. Okay, you see this. Okay, this is just before 1.42, this just after 1.44. So I mean, I will find out a gradient at 1.42, a gradient at that, and gradient at 1.44. Student, if this is positive gradient coming and here negative gradient, it means this going up and then coming down. So it's called point of maxima. But if time we have this situation also. Okay, this is a 1.43, just before is this gradient and just after is this gradient. So if we have a just before we have a negative gradient and just after positive gradient, it means first you coming down and then going up. So this point is called point of minima. So I'm going to show this concept. Get ready, and no need to find the second derivative in this criteria. So for example, I'm just saying, and you will ask one question to me, sir, how we can find gradient here? Derivative is also called gradient. So I will plug in 1.42 here and here and here. Look, I'm writing now here. Just before x value 1.42, I'm going to replace every x by same. So gradient I'm finding. So e to power 2 times to 1.42, 7 times to cos to power 1.42, and sine time to 1.42, and I'll get answer. I'm going to type, wait a minute please. 1.42. So first of all, e to power 2 times to answer, and bracket open, 7 times to cos answer. Okay, minus sine time to answer, and my answer is coming 1.07, which is positive. It means just before is a positive. It means we are going to get this answer. So just before, it means I have a positive gradient, positive gradient, positive gradient. And just after 100%, I will get what? Negative. Look, let's try. So just after. What is just after 1.44? I will plug in 1.44 where? I will plug in again here, again here. So I'm going to plug in. Let's see. So m is equals to e to power 2 times to 1.44, bracket open, 7 cos 1.44 minus sine 1.44 and 1.44 and close and close. So let's try it now. So 1.44. So exponential to power 2 times to answer, and then bracket open, 7 times to cos answer, and minus sine time to answer, and my answer is coming negative 1.39, because it's coming first positive then negative. So 100% we can say that just before I have a positive, just after I have negative. So you say that it is a point of maxima. Examiner will just see the signs. He will see that if you do this method in exam papers, you get a full marks. Okay. All right. So I just give an idea once again. For example, this point's given. Okay. I repeat. So just before, look, I draw a tangent at this point. So student, look at here. At this, draw a tangent. At this, tangent. At this, tangent. I believe, inshallah, you will understand. And this tangent. So look at now carefully. This is a point just before I have positive gradient and just after I'm getting a negative gradient. So this is called point of maxima. Okay, this is a turning point here. Just before I have negative gradient, just after I have a positive gradient is called point of minima. Hold on. Do you know, students, these are basic criteria. All these blue lines, they are positive gradient. On all these green line, they have negative gradient. Now see, this is a positive gradient and this is negative gradient. So it means gradient sign will help us point of maxima or point of minima. Okay, here it is not a hard to find differentiation, second differentiation, but sometime we are very common. For example, if I have this kind of question, e to power 2x sine double x over cos triple x. So this is a very hard to find second derivative. For example, this first derivative we have, and I have to find second derivative. It is a very hard to find second derivative in this kind of question. So this technique is very helpful in this kind of question where second derivative is very tough to find. So in this kind of question, what we do technique, and what the point you get it, please repeat here for you. So 1.43 is the turning point. Just before is 1.42 and just after 1.44. So this value I will plug in first derivative, not second derivative. Make sure if I get a positive answer, and just after I plug in there I got a negative answer. So first before positive, after negative. So this point is point of maxima, or sometime first negative after positive is point of minima. And I hope so the concept is very clear, how we can find nature without finding second differentiation.